Alrighty, so we're about to embark upon a brand new topic, and that brand new topic is something called stoichiometry. And the big thing we hear about when we think about stoichiometry is we read about this thing referred to or called moles. Okay? Mole is a chemistry term, and what a mole is equal to is it is equal to 6.02 times 10 to the 23rd. Now what is that of? Well, it's of atoms if the thing is pure. And what do I mean by atoms? It means if you have an element. So you have something like, copper. If you have something like carbon. If you have something like oxygen, etc., etc., etc. So if it's an element, it's an atom. Or we can use another term called molecules, or we can use another term called formula units. And molecules really just refer to things like O2, oxygen gas, N2, CO2, etc. But sometimes we can also have something called formula units. And what are formula units? They're just a fancy word for something that is ionically bonded, meaning you have a metal and a nonmetal. We sometimes will call that, or we do call that, a salt. So that's why NaCl is an example of one, right? But it could be like Cu, 2O, copper and oxygen together. Why? Because it's a metal and a nonmetal. We call those formula units. Now, what does this actually mean? Well, if I told you, that you have a dozen donuts, you would tell me you have 12, right? Or if I told you, we were going skating, right? And this was a pairs skate. Well, pairs would imply 2, right? So in our everyday jargon, we allow words to mean numbers, right? If I told you a baseball player got a triple, you would know he got 3 bases, right? Well, if I told you that we had a mole of cars, which I don't even know if there are a mole of cars in the planet, what that would mean is it would mean we have 6.02 times 10 to the 23rd of them. That would be a pretty gigantic number of cars. Okay, just to give you an idea of what that number, looks like, right? 6.02 times 10 to the 23rd. So to give you an idea what that would look like I was saying, is if we took this number, we put it right here, and we wrote it out, it would be 602, comma, and 21 zeros. So 0, 0, 0, 0, 0, 0, there's 6, 9, 12, 15, 18, and there's your decimal. So that's that number right there. Pretty much, if you have this many dollars, you'd own every dollar on the planet. Okay? So it is an enormous number. So I put a second question here, and it is this. Well, if it's such a big number, right, why do we have it? And the reason we have it is because atoms, molecules, and formula units are really, really, really small. So, they're really, really, really tiny when we think about these things here. And so what ended up happening was we needed a way to be able to be tangible about it. We needed a way to be able to take these elements and be able to actually have a lump of graphite, carbon. We needed to be able to quantify how many atoms were in a bar of gold. And so what ended up happening was we ended up taking carbon, and there was a guy named Avogadro. And what he did is Avogadro hypothesized that in 12.01 grams of carbon, there are 6.02 times 10 to the 23rd atoms of carbon. Okay, so this big number, itty bitty little atoms, makes up 12.01 grams of carbon. It's not a whole lot. But now we have a tangible way of expressing an amount that we can actually, measure out. We can measure out 12.01 grams of carbon, and we could utilize it. And so, because these things are so tiny, we came up with this term, mole, to give us a way to express it and to look at it. And thus, that's where it came from.